So in this session, we'll discuss the moment question and I will explain how you will solve such questions in which there is a turning effect of the force. Whenever a question involves a pivot or a point of rotation, we always solve these type of questions by assuming that object is in equilibrium or object is balanced. So in the first question, in a braking system of a car, the brake pedal rotates about a pivot. So as you can see, this is the point of rotation or a pivot is there. When the pedal is pressed, so we are applying a force on the pedal. So because of this 200 Newton force, which direction it will rotate, clockwise or anti-clockwise?
Clockwise.
So it will rotate, so means this will cause a total clockwise movement. And there is a liquid in the cylinder or oil is there that will also apply a force, or there will be force on the oil. Which direction it will try to balance or apply the force or force of the oil, that is, it will try to cause it rotate anti-clockwise. So one side it is causing a clockwise rotation, another side it will try to cause an anti-clockwise rotation. But whenever we solve these questions, we assume that object is in equilibrium or total anti-clockwise and clockwise moment are equal. So the formula, when object is in equilibrium, we always solve by using this method, that the total clockwise moment is equals to the anti-clockwise moment. So this is always the case whenever object is in equilibrium or object is balanced. So the clockwise and anti-clockwise moment will be balanced. Now, how to get the moment? Moment is the product of force and distance. So the force multiplied by perpendicular distance. So the first force, that is a 200 Newton force is there. You can see this is a 200 Newton force. And what is the distance? We always take a perpendicular distance from the point of rotation or a pivot. So the clockwise moment is due to a 200 Newton force, which is 22 centimeter from the pivot. And the anti-clockwise moment is due to the force F and at a distance of 8 centimeter from the pivot. So anti-clockwise moment is F, the force, multiplied by 8, the distance from the pivot, equal to the clockwise moment. The force is 200 multiplied by distance from the pivot, that is equal to 22. So if we need the force here, so we just simplify, that force will be equal to 200 multiplied by 22 divided by 8. What's the answer for this? 200 multiplied by 22, that is divided by 8.
550.
So this will be equal to 50 Newton. Is it clear, the first question related to turning effect?
No, it is 550.
550, okay. Is it clear, the first question? So remember the technique for solving such question in which there is a pivot or turning effect of the force. We always assume that the clockwise and anti-clockwise moments are equal. Another question, two mechanics A and B are trying to use a two-person spanner or a wrench on a large beam. Figure 2.1 shows the force exerted by the two mechanics. So mechanic A exert a force of 500, when mechanic B exert force of 400 at a distance of 1.2 from nut P. We have to calculate the magnitude and the direction of resultant moment on nut P. So this P is the point of rotation. Around this point or nut, the object will rotate. So because of this 400 Newton, which direction it will cause a turning effect? The 400 Newton force of mechanic B. Which direction it will? Yeah, this will cause a clockwise rotation. And which direction a force of 500 acting downward, but according to turning effect, which direction it will try to cause a rotation or a turning effect? That is anti-clockwise. So when we calculate the anti-clockwise and clockwise moment, these moments will not be balanced because this object is not in equilibrium. So when we calculate the anti-clockwise moment, the force is 500 and the distance from the pivot is 1.2. The force of mechanic A is 500 and the distance, the perpendicular distance between the force and the turning, the point of rotation, that is 1.2. So 500 into 1.2, what's the answer for this? 500 into 1.2.
600.
So that is equal to 600 Newton meter. And when we calculate the clockwise rotation, clockwise moment, the force is 400 and the distance from the turning effect from the pivot, that is 1.2. So 400 into 1.2, how much is it? The value?
480.
480. So this is 480 Newton meter. So which moment is more, anti-clockwise or clockwise? Which turning effect is greater?
Anti.
Anti. So means this object will rotate anti-clockwise. And how much, what is the resultant? How to get the resultant? 600 Newton meter is anti-clockwise and 480 Newton meter clockwise. So what will be the result? The result will be 600 minus 480, which is equals to 120 Newton meter. And what will be the direction of this turning effect? Because anti-clockwise is more, so it will rotate anti-clockwise. Is it clear? The first part, we calculated the resultant turning effect. Any doubt in this? Then we have a second part in which so magnitude is 120 and the direction is anti-clockwise. Then the mechanic B reverses the direction of the force. We have to now calculate the resultant moment and resultant force. So what mechanic B did, the mechanic B, first he was applying a downward force, now he is applying an upward force. So as the mechanic B reverses the direction, the turning effect will also change for mechanic B. A force of 500 Newton, we already know it was causing an anti-clockwise movement. Then a force of 400 Newton now, because as they mentioned, mechanic B reverses the direction of the force. So which direction this will cause a rotation or turning effect? Now it will be anti-clockwise as well. The two forces, even though the forces are in opposite direction, but their direction of the turning effect is same. So they're applying the turning effect in the same direction. So when we calculate the anti-clockwise moment for mechanic B now, that will be 400 into 1.2, which is equals to 480 Newton meter. And for mechanic A, we already calculated that was 500 into 1.2 equals to 600 Newton meter. Now we have to calculate the resultant turning effect. So how to calculate the resultant turning effect or resultant moment? Because two moments are acting in the same direction. So what we do, we add them as they're in the same direction. So 600 Newton meter is anti-clockwise by mechanic A and 480 Newton meter is also anti-clockwise by mechanic B. So what is the resultant? It will be 600 plus 480. So it will be 1080 Newton meter and the direction will be anti-clockwise. So that is the answer for part B. And what is the resultant force? So for resultant force, we don't need the distance from the pivot. We just check the direction of the force to get the result. This is a resultant moment. But if we need the resultant force, so if we need the resultant force, a force of 500 Newton is acting downward and 400 is acting upward as the mechanic B reverses the direction. So 500 is down, 400 is up, so their directions are opposite. So 500 minus 400, 100 Newton. And what is the direction of the resultant? That will be downward. So 100 Newton downward or down. So when you're calculating a resultant turning effect, you have to use the force as well as the perpendicular distance from the pivot. But when you're calculating only the resultant force, you just need the direction of the force. If they're in the same direction, you will add. If the forces are in opposite direction, you will subtract. You don't need a distance to calculate the resultant force. So this was the answer for the last part. Like here, the magnitude of the resultant moment when they changes the direction, that was 1080 Newton meter. And magnitude of the force 500 up, 400 down, so that is 100 Newton. In question 3, figure 2.1 shows a uniform plank. So when we say uniform plank, it means its weight is acting at the center. It is suspended by of length 2 meters, suspended by 2 ropes X and Y. The weight of the plank is 210, and the force on rope X is P and the force on rope Y is Q. State in terms of P, the moment of force P about B. So whenever they use the term about a certain point, means that is a pivot. So here about B means B is the pivot. So according to B, like considering B as a point of rotation or B as a pivot. So what is the turning effect of or the moment caused by this force? So how to work out this? Because we know moment is a product of force and distance. So how much is a force? If you want to calculate a moment, that is force multiplied by perpendicular distance. So how much is a force? That is P. Multiplied by distance from the pivot, as they already mentioned, about B. So point B is the pivot or point of rotation. So we have to take a perpendicular distance between the pivot and the force. So that's how much? 1.5. So it will be P multiplied by 1.5. So that is the moment or turning effect of the force P about B. Why we say about? Because in the question they mention about B, so it means B is the point of rotation or B is the pivot. Is it clear, part A for question 3? You can use your mic or a chat for any question or a query or doubt you have. Okay. Then next, calculate the moment of the weight about B. So we want the turning effect of the weight or turning effect due to the weight about B. So B is a pivot and a weight of 210 Newton is acting downward. So which direction it will cause a moment or a turning effect? It will cause a moment or turning effect in anti-clockwise. But we don't need the direction, we just need the turning effect. And about B, so B is the pivot. So force is how much? Weight is 210, so this will be 210 multiplied by distance from the pivot. So how will we'll identify what will the distance? Because it's a 2 meter long, the length is 2 meter and it is a uniform. Uniform means weight will act at the center. So if it is total is 2 meter, weight will act at the center. So what will the distance of weight from both ends? That's equal to 1 meter. So it will be 210 multiplied by 1, which is equal to 210 Newton meter. How I get 1 meter? Because they mentioned it is a uniform object. So for a uniform object, weight is always acting at the center. So it is 210 multiplied by 1, which will give same as 210. Then The next part, we need force P. How to work out force P? So whenever we want to solve a question related to turning effect to find the force or the distance, so here B is the pivot. They already mentioned B is the pivot or turning point of rotation. So the weight is causing which direction? The weight will cause a rotation. The weight is causing an anti-clockwise rotation. And the force P is there, which is acting upward. Which direction? This will cause a moment or turning effect. That will be clockwise. And if this object is in equilibrium or balance, as the object is in equilibrium, we'll assume this object is in equilibrium, so it will not rotate. Why I did not consider any turning effect due to this force Q? Because when force is acting on the pivot, the perpendicular distance is 0. That's why it does not cause any turning effect or rotation. So when we solve, again we will assume the clockwise rotation and anti-clockwise rotation will be same. So anti-clockwise moment is how much? It is 210. The force multiplied by distance from the pivot, that is 1. And the clockwise rotation, that is due to the force P is there, multiplied by perpendicular distance from the point of rotation 1.5. So this 1.5 is multiplied, other side divided. So 210 divided by 1.5, this will give us the value of P. What is the answer for this? 210 divided by 1.5. $210 divided by 1.5. What's the answer for this? $140. Okay. So the force here, the P equals 140 newtons. So we work out the force P, that is equals to 140. And the last part, we need force Q. So if we need, so we already worked out this is 140, this is 210, this Q is unknown. So whenever we are solving a question related to, like the last part is there, we can also consider as the object in its equilibrium, there is no resultant force. So the total upward force, when object is in equilibrium, there is no resultant force. So the total upward force is equals to total downward force. The total upward force, the force which is acting upward, that is 140. That is P which is acting upward, and Q we don't know. Equal to total downward force, which is 210. So if we need Q, 140 is added here, other side will be subtracted. So 210 minus 140, that is equals to 70 Newton. So the force Q is actually equals to 70 Newton. As it is 70 Newtons, the total upward force is 210 because 140 plus 70, 210, and total downward force is also 210. So first part, when we need the force, we solve the first part by considering the condition of equilibrium that there is no resultant turning effect, and we solve the second part by considering that there is no resultant force. Is it clear how to work out value of Q? Then another question, figure 4.2 shows an elephant which is pushing horizontally against a vehicle with a force of 11 kilonewton or 11,000 Newton. So elephant is applying a force of 11,000 Newton. So elephant is applying a force of 11,000 Newton. And at a distance of 1.8 meter above the ground. So he's applying a force 1.8 meter above the ground. So point M is the center of the mass. Center of mass means where the weight of the car is acting. Calculate the moment about A for the force exerted by the elephant. So as we can see again, in the question they mention a turning effect about point A. So if you want a turning effect about point A, means A is a pivot or A is a point of rotation. So if A is a turning, A is the point of rotation or A is a pivot. So how to calculate a moment? Moment is a product of force multiplied by perpendicular distance from the pivot. So how much is the force? This is 11 kilonewton or 11,000 Newton. So 11,000 Newton is the force and distance from the pivot, the perpendicular distance from the pivot is 1.8. So 11,000 multiplied by 1.8. So this will give us how much turning effect is caused by the elephant. What's the answer for this?
19,800.
So this is 19,800. Newton meter. The next part, the mass of the vehicle is 1900. And it does not slide when pushes by the elephant. Determine whether the elephant tips the vehicle over. Show your working. So what we have to do, we have to find which turning effect is more. If the turning effect due to the elephant is greater, then the turning effect due to weight of the car, this vehicle will topple. But if the turning effect of the weight is more than the turning effect of the elephant, then it will be stable. Because the elephant is trying to topple this car or trying to cause an anti-clockwise rotation, where weight is acting downward, then that is trying to keep it stable or causing a clockwise moment. So the moment or turning effect due to the elephant, we already calculated. It was 11,000 multiplied by 1.8. So it was 19,800. 11,000 into 1.8 was 19,800 Newton meter. So that is a turning effect due to the elephant. But now to calculate the turning effect due to weight of the car, so mass of the car is 1900. So what will be the weight of the car? Because weight is mass.
19,000.
Yeah, good. Weight is mass multiplied by gravity, 1900 multiplied by 10. So weight will be 19,000 Newton. So weight of the car is 19,000, which is acting downward. And the distance from the pivot, the perpendicular distance from the pivot, because they mentioned point A is a pivot, so that is 1.2. So if we calculate the turning effect due to weight of the car, it is 19,000 multiplied by 1.25. How much is this? 19,000 into 1.25. 19,000 multiplied by 1.25. What's the resultant moment?
23,750.
So 23,750 Newton meter. So the moment or turning effect due to the car is more than the turning effect by the elephant. So means this elephant cannot topple the car or this car will remain stable. So we have to determine whether the elephant tips the vehicle over. So I will write the answer and we'll show our calculation like moment of the elephant or moment by the elephant. That was 19,800 Newton meter and moment by weight of the car. that is 23,750 Newton meter. So it shows that the weight of the car, the moment or turning effect due to weight of the car is more than the elephant. So this elephant cannot tip the vehicle. Is it clear, this part, that how I work out that elephant cannot topple or roll over this vehicle, as the turning effect of the weight of the vehicle is causing a greater moment as compared to a turning effect due to the elephant. The elephant was causing only a moment of 19,800, but the weight is causing a greater turning effect. So that will make it stable. Okay, moving on to another question. This question is related to equilibrium. State two conditions necessary for a system of forces acting on a body to be in equilibrium. Like, what are the two conditions of equilibrium for object to be in equilibrium? There should be no resultant turning effect. Or we can also say the clockwise movement is equal to anti-clockwise movement. That is one condition. And the second condition, there is no resultant force. Or we can say that the total upward force equal to downward force. So these are the two conditions. Either you can just mention no resultant moment, no resultant turning effect. Then the next part, figure 1.1 show a loaded wheelbarrow held in equilibrium by a gardener. So this gardener is keeping it stationary, stable. The wheelbarrow is in contact with the ground at point C. Figure 1.1, there are three vertical forces are there. Two of them are acting upward and one is acting downward. The P is the upward force which is applied by the gardener. Q is the upward force which is applied by the ground. And W is the weight of all the things that is acting downward. Explain why the force P is less than W. So why the force P will be less than W? What is the reason? Look, if we apply because they already mentioned it is in equilibrium. So if it is in equilibrium, according to equilibrium, there will be no resultant force, or the total upward force will be equal to total downward force, as there is no resultant turning effect or no resultant moment. So the upward force, that is P, which is acting upward, Q is acting upward. So the two forces which are acting upward, P plus Q. And what about the downward force is W. So basically, sum of P and Q is equal to W. According to the condition of equilibrium, as it is in equilibrium, the upward force equal to downward force. So actually, weight is equal to sum of P plus Q. So it means Q can never be equal to weight, because weight is equal to P plus Q. So definitely Q will be smaller than the weight. As it is, the sum of P and Q gives us the weight of an object. So here, by considering the forces P, Q, and W, explain why P is less than W. So what is the reason? You will mention that as it is equilibrium, the weight is equal to P plus Q. So P will always be less than W or smaller than W, because the sum of the P and Q will give us W. So definitely P will be smaller than W, as the sum of P plus Q is giving us weight of an object. Is it clear, the first part, like why the P is always less than the weight? Then the second part, by considering the turning effect of P and W about C, why in terms of turning effect, we have to tell why P is always less than W. Look, when we are calculating about C, so C is a pivot, C is a point of rotation. So this is causing a clockwise rotation and weight is causing an anti-clockwise rotation. So as it is in equilibrium or it is balanced, the total clockwise moment and anti-clockwise moment will be same. So if I want the clockwise and anti-clockwise moment to be same, as you can see, P is acting at a greater distance from the pivot. Yes, that's right, Rafik. As you can see, P is acting at a greater distance. And W or weight is acting at a smaller distance from the pivot. So the forces, if two forces are in different quantity, like example, if I say this is X and this one is Y. So P into Y, like P into Y equals to W into X. Because the X is smaller, so weight should be greater. Here Y is greater, so force should be small. So when objects are in equilibrium or balance, so those forces which are acting closer to the pivot, they are having a greater value as compared to a force which is acting away from the pivot. So reason here, you will mention the clockwise moment is equals to anti-clockwise moment. That is one thing. And then P is acting away from the pivot, so that's why it is smaller. And weight is acting closer to the pivot, that's why it is larger or a greater value. So whenever two objects we want to balance by different forces, so a force which is acting away from the pivot is much smaller as compared to a force which is acting closer to the pivot. So if I say this one is 2 and this is 4, this one is say 30. So if I want a turning effect, so this will be 15 because 30, this will cause a turning effect 30 multiplied by 2, 60 Newton meter. This will cause a turning effect 15 multiplied by 4, that is also 60 Newton meter. So both turning effects are same, 60 Newton meter, but you can clearly see the force which is closer to the pivot is larger and the force which is away from the pivot is smaller. So in terms of moment, why P is smaller than W? Because P is acting away from the pivot and W is acting closer to the pivot. Is it clear, this part? So first one, we have to tell in terms of forces, why P is greater than, P is smaller than W. And the second one, why in terms of moment, why P is smaller than W. Another question related to the part is there. Figure 1.2 shows a kitchen cupboard resting on a support attached on a wall by a screw. The weight of the cupboard and the content is 75 Newton. The clockwise and anti-clockwise moments are balanced about point P. So if they say about point P, so this is about point P, it means P is the pivot. So we want to calculate the force F. This force F we have to calculate. This point P is a pivot. With direction, this 75 Newton will cause a rotation. A weight
Clockwise.
so that is a clockwise. So how much is this? The moment turning effect 75 into 0.24. So 75 into 0.24, what's the answer? Seventy-five. Can you repeat what you said?
24 Newton.
No, the final answer, not the final answer. I'm just asking 75 into 0.24. Okay, it is 24, this one. 75 multiplied by 0.24. Not the final answer, only this one.
18.
18.
18. Okay. So this is 18 Newton meter. That is the clockwise rotation. Then another force F is there, which is causing a rotation or try to cause a rotation anti-clockwise. That is a force F and a distance from the pivot is 0.75. So how much is turning effect? F into 0.75. But because this object is in equilibrium, so the total clockwise and anti-clockwise moment will be balanced. So if the clockwise and anti-clockwise moment will be balanced, the anti-clockwise moment is F into 0.75 and clockwise moment is we already calculated, which is 18 Newton meter. So F is equals to 18 divided by 0.75. 18 divided by 0.75, that's equal to 24 Newton. So this force which is acting is 24 Newton. And you can see, you can easily identify because this force is acting away from the pivot, then it is a smaller force. The one which is closer to the pivot, that is a larger force. So when object is in equilibrium or balance, the total clockwise and anti-clockwise moments are equal. So by using the direction of the force and the position of the pivot, you have to first identify the clockwise and anti-clockwise moments and just equate them by using the condition that the anti-clockwise moment are equal to clockwise moments. Question 6.